Hey guys, so let's start with the new chapter, chapter 18, known as reinsurance. So, what do you mean by reinsurance? Okay, we as an individual take insurance or protection from an insurance company, right? So, suppose as an individual, I'm worried that if I die, then there would be a lot of financial burden on my family, right? Lot of financial burden. So instead, what do? I go to an insurance company. Suppose I go to HDFC and tell them कि भाई मेरे को डर लग रहा है मैं मरेगा तो क्या होगा. So instead you give me an insurance cover. So it gives you an insurance policy. ठीक है, policy देंगे. Okay. So in that policy it is stated that if I die, okay, then it will pay my family. Okay, my family मतलब मेरे बच्चे, my wife, okay, my mom, dad, everyone, it will pay total 5 crore rupees. Okay, and I will pay the company, okay, suppose 50,000 rupees in order to giving me this protection. Okay, so this is the simple fund of insurance company. Now अभी इंश्योरेंस कंपनी को डर लग रहा है कि भाई मैंने मोस्टली ज्यादा पॉलिसी बेच दी है, अब मेरे को डर लग रहा है सपोज ज्यादा क्लेम्स अगर मैं लॉस में आ गया तो सी ही इज टेकिंग ओनली 50,000 एज द कवर and paying out 5 crore rupees. So suppose he is considering that per 10,000 people only one person will die. Okay, he is considering that. But what if 2% dies? भाई ये तो 5 crore की कंपनी नुकसान में आ गई. So what does it do? उसको डर लग रहा है. Now HDFC is like frightened. What will happen to me? So उसके बोर्ड ऑफ डायरेक्टर्स ने बोला कि भाई चलो अपन री इंश्योरेंस कंपनी के पास जाते हैं. सपोज द री इंश्योरेंस कंपनी स्विस रे. Okay, Swiss Re is a reinsurance company based in Switzerland. It has a company here in India. Okay, it goes to Switzerland and buys reinsurance. Okay, this is what reinsurance exactly means. It means that it is an insurance for an insurance company. Okay, इसके जो risk है of an insurance company, it goes to another company known as insurance. Okay, so this is the basic idea of what it is. Okay, वापस एक बार बोलता हूँ, अगर इंश्योरेंस कंपनी को डर लग रहा है और वो एक इंश्योरेंस पॉलिसी ले रहा है इन ऑर्डर टू कवर इट्स लॉसेस, then in that case it is known as a reinsurance. As the word suggests, reinsurance, insurance का insurance, reinsurance. Okay, simple. So what does this main insurance policy covers? It covers nothing but, what does it covers? It covers, or it protects itself from large claims. मैंने बोला ना, अगर दो पॉलिसी आ गया मतलब क्या होगा, दो क्लेम आ गया तो लॉस होगा ना. सो इन दैट केस इट प्रोटेक्ट्स अगेंस्ट लार्ज क्लेम फॉर एन इंश्योरेंस कंपनी. अपने लिए ना इंश्योरेंस कंपनी को प्रोटेक्ट करता है. या एंड इसके एडवांटेज क्या है? एडवांटेजेस आर of buying a reinsurance. Okay, advantages are it reduces average claims. तो जो claims होता है वो कम हो जाता है. How it goes less, everything. We will literally see sums where we'll compare the averages. Okay, so you will get an idea. Okay, right now just understand कैसा होता है. And second point is जो variability होता है ना claim का, variability, variance, okay, वो भी कम हो जाता है. Variance reduces for an insurance company. ये advantage are for an insurance company. So this is the basic idea of what an insurance is. Okay. Now, moving ahead, there are two forms of insurance: proportional reinsurance, okay, and excess of loss reinsurance. The short form of excess of loss is also known as XOL. Okay, so let us evaluate each and everything. Okay, हम लोग समझेंगे क्या हो रहा है in each and every case, and then we will also solve a few sums. Okay, Let me give you a brief idea. This chapter is all about sums. Okay, ये chapter से one sum guarantee आने ही वाला है, 110% आने ही वाला है. I'm telling you. So solve this properly. इसमें ना calculation mistakes like ज़्यादा हो सकता है. So please make sure you do not make any calculation mistakes. Okay. Please see what number you are picking. Okay. These are the common mistakes which happen. Okay. So ध्यान रखना. Okay. Common mistakes. First calculation mistakes हो सकता है. Second, wrong number pick कर रहे हो. Okay. Wrong number pick करना. That is the second mistake that happens. Third mistake is formulas. Okay. Formulas में गड़बड़ होना. Calculation mistakes होना. मतलब वैसा mistakes. Okay. These are the three common mistakes which students make. Therefore, IFOA tends to ask one question 100%. Okay. चलो moving on to the story part. Reinsurance. What do you mean by a proportional reinsurance? Okay. So proportional reinsurance, same example लेते हैं. HDFC. Okay. HDFC goes to Swiss Re to buy reinsurance. Okay. Swiss Re to buy reinsurance. ठीक है. It buys a proportional reinsurance where your proportion, okay, of your HDFC is 70% and your proportion of your Swiss Re is 30%. हमेशा total would be 100% ना. हमेशा हमेशा हमेशा. Okay, what does this indicate? This indicates that if 1000 रुपया claim आया, suppose we last time example के हिसाब से 1 crore claim आया, in that case, okay, 70 lakhs would be paid by HDFC क्योंकि उसका 70% है. So 70% of 1 crore is 70 lakhs. Similarly, 30%, which is 30 lakhs, would be paid by Swiss Re. That is the reinsurance company. So this is what it indicates. हमेशा जितना भी क्लेम आया, ओके, जितना भी आया, 100 करोड़, 500 करोड़, 1000 करोड़, 10 लाख करोड़, 0 रुपीस, कुछ भी क्लेम आया, then that claim का 70% would be paid by HDFC, 30% by the reinsurance company. This is what proportional reinsurance means. That is equal sharing of premium and claims. So ये स्विस रे है, वो प्रीमियम का 30% लेगा, HDFC प्रीमियम का 70% लेगा, एंड 70% ऑफ द क्लेम्स वुड बी पेड बाय HDFC, 30% स्विस रे. अल्फा इंडिकेट्स रिटेन्ड प्रोपोर्शन. रिटेन मतलब मैं कंपनी क्या रिटेन कर रहा हूं. एवरी टाइम us as a company is the insurance company. Okay, every time. Okay, so your insurance company is what? Yeah, it's perfect. It's HDFC. And what is the reinsurance company here? Reinsurance company is Swiss Re. Here in this example, okay? 30% proportional reinsurance question में पूछा है. This means 30% proportional means 30% is taken by Swiss Re, reinsurance company. So 30% proportional means मैंने 30% नहीं, मैंने 70% लिया है. Similarly, 25% कोटा शेयर means कि reinsurance कंपनी ने 25% लिया है, मैंने 25% नहीं. मैं मतलब HDFC, okay? Insurance company. So, in order to identify 90% of the case, okay? 90% of the case, okay? 90%, 99 लिखता हूँ, okay? बस I'm giving you surety. 99% of the claims, 50% से ज्यादा का जो proportion है ना, that would be always taken by your insurance company. हमेशा. Even you see 30% है, 70% is taken, which is greater than 50. Here 75% taken by the insurance company, which is greater than 50. So 50% से ज्यादा है, that is always taken by insurance company 99% of the time. There could be one way or some where ये सब हो सकता है, वो लोग ने मस्ती कर लिया तुम लोग के साथ, then you guys have been pranked. Okay guys. Okay, so carefully read the question. 30% proportional means 30% मेरा नहीं. Okay, reinsurance. अगर मैं बोलूं 60% प्रपोर्शनल, देन 60% मेरा नहीं री इंश्योरेंस कंपनी का, 60% कोटा शेयर बोलूं, ओके, देन 60% मेरा नहीं री इंश्योरेंस कंपनी का, ओके, गेट दैट थिंग स्ट्रेट इनटू योर हेड। और प्रोपोर्शनल इंश्योरेंस क्या होता है? प्रोपोर्शनल इंश्योरेंस पेज अ प्रपोर्शन ऑफ योर क्लेम। 30% प्रपोर्शन होता है, तो 30% क्लेम्स आर पेड बाय होम? री इंश्योरेंस कंपनी। ओके गाइस, ठीक है, री इंश्योरेंस, आई होप द कॉन्सेप्ट इज क्लियर। लेट्स लुक एट द फॉर्मूला। Okay, you can make out from the formula. Okay, so alpha, let us यहाँ पे ही, okay, we'll make out with this example only. Okay, this is the formula. Do not see this side. Okay, this is बाद में will do. So 70% is taken by that. So 70% of the total claims is taken by whom? Is taken by an insurance company. See, Y indicates insurer का claim, X indicates total claim, Z indicates reinsurer claim. वापस देख रहे थे, X टोटल, Y अपन, Z reinsurance कंपनी। तो अपन के लिए क्या हुआ? अल्फा इंटू टोटल क्लेम। सो टोटल क्लेम क्या हम लोग ने यहाँ पे लिखा था? 1 crore इंटू 70%, 70%, which is nothing but X into alpha, or you can write alpha X anywhere, alpha X। एक्सपेक्टेशन लिया, टेक एक्सपेक्टेशन ऑन बोथ साइड, ये कांस्टेंट है, सो एक्सपेक्टेशन ऑफ एक्स, वेरिएंस ऑफ वाई, ठीक है, variance of y would be nothing but variance of alpha x, right? If I'm taking constant out of variance, it becomes square, so alpha square variance of x. This is how your formula came into existence. Simple, right? Similarly, z के लिए क्या है? 30%। Z मतलब री इंश्योरेंस कंपनी, अपन नहीं री इंश्योरेंस कंपनी। तो री इंश्योरेंस कंपनी के लिए इट वॉज वॉट? 1 crore into 30%, which is also 1 minus 70%, which is nothing but x into 1 minus alpha। देखो, x into 1 minus alpha। सिंपल, राइट? जो वो प्रपोर्शन पे करेगा मल्टीप्लाइड बाय टोटल क्लेम, उतना ही है फॉर्मूला। जस्ट अल्फा इज डिनोटेड फॉर अपन, 1 minus alpha for reinsurance company. That's it. That's the basic funda. I'm using a Mawali type language. Sorry, guys, but this is the way you will remember. Okay, so sorry, guys, if I have hurt you in any ways. I don't. I know I have not, but then also ठीक है, cool, चलो। Expectation of Z, take expectation both side. Constant का expectation नहीं होता, it becomes expectation of X. Similarly, variance of Z becomes variance of 1 minus alpha X। 1 minus alpha को बाहर लिखा हो लो, constant out square variance of x। See, simple, right? Yeah, y क्या? Y indicates अपन, insurance company, Z indicates reinsurance, X indicates total। Okay, ठीक है, cool। Now excess of loss insurance. So what does excess of loss insurance basically mean? Okay, excess of loss insurance, suppose, okay, let's take an example of same HDFC Swiss Re। HDFC goes to Swiss Re, okay, Swiss Re, Swiss Re को बोलता है, भाई तू है ना, तू मेरे को बचा, let me buy excess of loss reinsurance, okay, excess of loss reinsurance for $200, okay, for of value 200, sorry, of your value 200, M, M basically indicates your excess of loss। So what does excess of loss indicate? So excess of loss suppose 200 है। So in this case, हाँ, जितना भी 200 के नीचे वैल्यू होगा ना would be paid by me, और जितना भी ऊपर हुआ ना would be paid by another one, that is Swiss Re, that is a reinsurance company। So अपना excess of loss in this case क्या है? 200। अगर 200 क्लेम आया, टोटल क्लेम, हाँ, एक्सेस ऑफ लॉस 200 है, तो 200 के नीचे जितना भी होगा मेरे को भरना पड़ेगा। So total I have to pay 200। Okay, और ये दोनों का difference would be paid by reinsurance, which is 0। If you see, I have made a graphical representation also। Excess of loss is at 200 value, तो ये जो ऊपर के वैल्यूज है ना, दैट वुड बी पेड बाय योर री इंश्योरेंस कंपनी, ओके, एंड जो नीचे के जितने भी वैल्यूज है वुड बी पेड बाय मी, ओके, सिंपल लॉजिक। सो अगर 220 है, एक्सेस ऑफ लॉस 200 बोलता है, तो मैं तो 200 ही भरूंगा, बिकॉज उतना ही मैं भरूंगा, बिकॉज जितना भी ऊपर आए वुड बी पेड बाय री इंश्योरेंस। सो दिस वुड बी 200, और डिफरेंस जो भी हुआ इट इज पेड बाय री इंश्योरेंस कंपनी। सिमिलरली 300 आया, 300 में क्या होगा, इन दैट 300 के, 200 के नीचे जितना भी आया मैं भरूंगा, मैक्सिमम मैं 200 ही भरूंगा। So in that case, this would be 200 and remaining paid by reinsurance. Similarly, 180. Okay. So 180 में क्या होगा? It would be 200 के नीचे जितना भी आया तो मैं भरूंगा. So 200, 180 is less than 200. So everything would be paid by me. Similarly, 100 में भी everything would be paid by me. So basic formula of your Y is maximum of the total claims or your reinsurance amount. So minimum, my bad. Minimum of your total claims or or your retention value. जो भी कम हुआ वो. This is the basic formula, okay? This is your concept for reinsurance, okay? Excess of loss reinsurance. Let us have a quick view with respect to the formula, okay? If we were to evaluate it, Y मतलब कौन? अपन, अपन. So Y के लिए क्या होगा? Your total claim, if your claim is less than equal to your retention, अगर retention से ऊपर हुआ, then it would be M, right? You can see, अगर 180 हुआ, 180 is less than 200 ना, so it is 180, see 180. If it is 300, 300 is greater than 200, in that case, it would be 200, your M value, okay? So, this is how it is. Similarly, Z, it would be 0. If your X is less than M, that means the total claim is less than retention, then 0. Take 180 का example only, okay? 180 में reinsurance company कितना दिया? 0, क्योंकि सब कुछ अपन दे रहे हैं. Therefore, if it is less than your retention value, that's 0. If it is more, then it is the difference between those two. If you see, यहाँ पे भी 300 रुपए में क्लेम में अपन ने 200 ही भरा, क्योंकि रिटेंशन उतना ही है, एक्सेस ऑफ लॉस का रिटेंशन. Okay, retention is your excess of loss or retention limit, okay? लिमिट होता है वो, अपन इसके ऊपर भरेंगे ही नहीं, कुछ भी हुआ दादागिरी, okay? Simple. So if this is greater than M, if you can see, अगर 300 हुआ तो 200 मैं भरूंगा, जो डिफरेंस हुआ वो इंश्योरेंस भरेगा. So difference, ठीक है? Let's evaluate the formula. So let's start with expectation of Y. Expectation of Y क्या? Okay, integration from 0 to M x f of x dx. Greater than M के लिए, M to infinity, it would be M f of x dx. Similarly, expectation of Z के लिए, integration from 0 to M, 0 to M के लिए 0 into f of x dx. Okay, and integration from M to infinity, x minus M f of x dx. Right? So this is what it is going to be. Expectation of y square करने जाऊं मैं, expectation of y square, then ये value square होगा, everything else remains as it is. So let me write that. It would be nothing but integration from 0 to M x square f of x dx plus integration from M to infinity M square f of x dx. Similarly, our expectation of z would be, ये 0 है, so I'm just ignoring it, okay? Now क्यों लिखना है? 0, anything multiplied by 0 is 0, so we can just ignore it. Let me just cut it out with a red color pen. ऐसे लगना चाहिए कि काटा है अपने उसका, ठीक है? So expectation of z is m to infinity x minus m f of x dx. Simple, right? और x minus m square because expectation of z square कर रहा है. Cool. Your variance of y, what would be variance of y? It would be nothing but expectation of y square minus expectation of y the whole square. अपना basic formula. Variance of z would be nothing but expectation of z square minus expectation of z the whole square. Okay, basic. Now there is one property which I would like to tell you. So x is equal to y plus z. जितना इंश्योरर बन रहा है, जितना री इंश्योरर बन रहा है, दोनों को क्लब करो, इट इज नथिंग बट द टोटल अमाउंट ओनली. यहाँ पे भी देख लो, 70 lakhs plus 30 lakhs is total amount only 1 crore. So x plus y. Expectation of x is equal to expectation of y plus expectation of z. Okay, अगर मैं expectation लूँ, then this equation would hold true. But variance of x won't be equal to variance of y plus variance of z. Okay, if you see the logic, okay, let me show you the logic. Variance of x is equal to variance of y plus z. It would be variance of y plus variance of z plus 2 covariance of y comma z. Guys, so that is why this is not equal. Okay, so like समझ जाओ. Now whatever I am stating this as an important thing, रट्टो फाइट. ये लेक्चर जैसे खत्म होता है, पहले रट्टो फाइट. Why रट्टो फाइट? Okay, because this chapter is all about sums. हम लोग जो next lecture में करेंगे sums, I will directly use the formula. So I won't see back and देखूंगा कहाँ formula था and so on. Okay. So this formula, रट्टो फाइट. रट्टा मार लो चलेगा. You spend 2 hours this before starting the second lecture, it's okay. But रट्टो फाइट guys, I'm not even kidding. रट्टो फाइट नहीं समझेगा आगे का chapter. And similarly, this formula, रट्टो फाइट. Okay, guys, I'm giving you a shortcut trick. Do not tell anyone. Okay, अपन के लिए ही है. So I can write this expectation of y into several forms. Okay, I'm just writing it down. Okay, this can be used to make your calculations easier. Okay, integration from 0 to m x f of x dx. Now this nothing but it doesn't indicate m is a constant. I can take it out. Integration from m to infinity f of x dx. Doesn't it indicates इतना ही part. Okay, I'm highlighting उतना ही part. ये आपको ऐसा नहीं लग रहा है? Doesn't it indicates that this is nothing but probability value, PDF probability value from m to infinity, which is nothing but probability value of greater than infinity, greater than m. मतलब m to infinity हुआ ना ideally. So basically you can write your expectation of y as integration from 0 to m x f of x dx plus m probability of x greater than m, and this can be also wrote as 1 minus f of x, that is the CDF. So wherever the CDF exists, instead of solving the integration which is time consuming, you could directly solve with respect to your CDF, putting the CDF value. CDF में substitute कर the parameters, it would be easier. Once you solve some, now you will get an idea. But guys, रट्टो फाइट. Okay, मैंने जितना बोला रट्टो फाइट. Now you have to even रट्टो फाइट this box as well. ये एक्सपेक्टेशन ऑफ y का ही है, ओनली एक्सपेक्टेशन ऑफ y का है दोनों साइड पे. ठीक है, सो रट्टो फाइट. As well as that, I will be doing two properties here. Okay, these properties are written in your tables book. Okay, it would be in page number, let me see and tell you कौन से page number पे है. Okay, that two property I'm doing a proof. Okay, so that's okay. It's on page number 1818. Okay, let me write it down for you so that you could see it. 1818. Okay, ऊपर normal distribution है, नीचे log normal है. So I'm doing the log normal distribution का proof. Then we'll do normal also. With that, we'll be done with this lecture. Next lecture is all about sums. Okay. So yeah, let's move ahead to your log normal property now. Hey guys, so let's prove the log normal distribution. So starting with it, this is your LHS. You have to prove that your LHS is equal to RHS. Okay. So let's start with it. LHS. LHS is equal to integration from L to U x raised to k f of x dx. Okay, this is your LHS. Let us prove it. So what we'll do first, let us substitute the value of f of x right here. Okay, it would be f of x of what? Of a log normal distribution. Okay, so perfect. Going ahead, it would be 1 upon root 2 pi x sigma e raised to minus half log x minus mu upon sigma the whole square dx. Okay, so this thing is from a log normal distribution ka PDF. Okay, let me write it for you because you are doing it for a log normal property. Okay, log normal distribution, therefore it follows. Wait, I will just write it down for you. Your x follows log normal distribution with parameter mu and sigma square. Cool. So moving ahead, okay, let me do some manipulation. Remember substitution manipulation T likhte the, we'll do that. Okay, and then we'll come up with our answer. So starting with it, let your log x minus mu upon sigma minus k sigma is equal to t. Okay, this I have defined as t. So let us keep x on one side, everything on another side. Okay, so first I will put log x minus mu upon sigma is equal to t plus k sigma. I just kept this on this side. Okay, so I'm naming this one. Okay, then let us multiply it by sigma and add mu. I'll get log x is equal to t plus k sigma. Okay, multiplied by sigma. Okay, plus mu is equal to log x. So basically your log x is nothing but t sigma plus k sigma square plus mu. Your x would be nothing but e raised to t sigma plus k sigma square plus mu. This I'm naming this as 2. Okay. I'm derivating your first variable with respect to x on both sides. I will be left with 1 upon x sigma. Why 1 upon x sigma? Mu upon sigma ka derivative would be 0 because it's a constant. Log x upon sigma ka it would be 1 upon x into 1 upon sigma, which is 1 upon x sigma. Okay, right here is equal to t ka aayega dt and k sigma does not have an x term, therefore it would be plus 0. Okay, derivative of constant is 0, therefore we are just ignoring it. Okay, I'll name this as 3. Okay, now talking about the limits. When your x is equal to L, okay, then your lower limit, okay, would be nothing but LK. Okay, LK is this. Okay, so what is LK? यहाँ पे मैं substitute कर रहा हूँ value. That's it. It is log of x के बदले it would be L minus mu upon sigma minus k sigma. When your upper limit is mu, okay, then it would be nothing but UK. Similarly, यहाँ पे I'm just substituting it. Okay, you will get your UK value. So using these four things, 1, 2, 3, and 4, okay, let's write our equation. It would be integration from LK to mu k now because of this part, right? Perfect. Then it would be x raised to k. So x raised to k को तो नहीं लिख सकता. I have to write x in this format. So it would be e raised to t sigma plus k sigma square plus mu the whole raised to k. Okay. Y multiplied by k e raised, sorry, in law of indices a raised to m the whole raised to n is a raised to m into n. Okay. Then 1 upon root 2 pi remains as it is. Okay. 1 upon x sigma, that is this part, okay, becomes your dt. So dt right here, and it would be e raised to minus half, okay, t square t plus k sigma square. Why t plus k sigma square? You can see it from your part 1. Part 1 से, okay. Let me just highlight it for you. See, part 3 ये है, which I have written it right here from this part, okay. I'm not highlighting it here because ज़्यादा confusion create होगा. And this part, okay, is written right here. And finally, your x part is written right here. Cool. You got your equation. Now let us simplify it. 1 upon root 2 pi. Okay, e raised to k mu को मैं बाहर निकाल सकता हूँ, right? K mu को k multiplied by mu, okay? K multiplied by mu, and I can remove k sigma square also, na? Let me simplify. बाद में remove करता हूँ, okay? So it would be better for you to visualize. Lk mu k, it's e raised to t sigma k multiplied by each and every term, okay? Plus k square sigma square plus k mu, okay? K mu I've just taken it out, so I'm not writing it here वापस. Okay, e raised to minus half. A plus b the whole square का क्या formula? A square plus 2ab plus b square. Okay, minus half ऐसा का ऐसा रहेगा. Now this would become nothing but 1 upon root 2 pi e raised to k mu integration from lk to mu k. Okay, e raised to t sigma k plus k square sigma square minus half t square. I'm just writing under one case only. Why one case? Again the law of indices. A raised to m into a raised to n is equal to a raised to m plus n. Okay, the law of indices. Okay, minus half 2 gets cancelled. I'm left with minus k sigma t and minus half of k square sigma square. Let us simplify. This and this gets cancelled, and I will club this and this. Okay, so yeah, I will club this and this. So I will be basically left with 1 upon root 2 pi e raised to k mu integration from lk to mu k e raised to minus half of t square minus half, this plus 1 becomes plus half of k square sigma square, right? So this much you got. Now can I take this out because it does not have a t term? I can take it out now. So I'm just taking it out. 1 upon root 2 pi e raised to k mu plus half of k square sigma square. Okay, integration from lk to mu k. Okay. Oh, shit. I forgot 1 upon root 2 pi. Lol. I forgot this term. Sorry, guys. No, I have written it out. Sorry, my bad. I have written it out. I'm just writing it in the bracket now. Okay, 1 upon root 2 pi e raised to minus half t square. Now guys, just give it a thought for a minute. Can you think anything of this equation? I hope you may have thought. Okay, this doesn't look like x follows standard normal distribution with parameter 0 and 1. Right now it is in that form only, na? So basically, this is nothing but e raised to k mu plus half of k square sigma square probability that t, the random variable is t here, t is between lk and mu k. Or I can write this in the form of e raised to k mu plus half of sigma square k square CDF of mu k minus CDF of lk. So now this is equal to RHS. If you see, this is equal to your RHS right here. With this, we can tell that your log normal property is proved. Okay, moving on to the second property and the last property for the lecture. Okay, then we'll be solving some in the next lecture. Okay, so moving on to the last property, it is known as the normal property. Okay, normal property. What is that property? Let us see. It is from your page number 18 on your tables book. Okay, actual tables book. It is nothing but integration from 0 to L x into f of x dx is equal to, sorry, integration from L to mu, sorry, my bad, L to mu x into f of x dx is equal to mu, okay, mu CDF of mu u dash minus CDF of L dash minus sigma, okay, PDF PDF of u dash minus PDF of L dash. Okay, what is u dash? U dash is nothing but L minus u upon sigma. Okay, guys, this is mu. Okay, mu. ये mu वाला mu है and this is u वाला u. Okay, this is u वाला u. Your L dash would be nothing but L minus mu. Okay, this mu upon sigma. Okay, so let us prove that now. Okay, so starting with the proof. Okay, so let's start with LHS. LHS is equal to integration from L to U x into f of x dx. Let me just write what is f of x here. F of x what? Normal distribution. Okay, just writing it down. Integration from L to U x into 1 upon root 2 pi sigma e raised to minus half x minus mu upon sigma the whole square dx. Okay, so now again manipulation substitution. Okay, your x minus mu upon sigma be equal to t. Okay, therefore your 1 upon x sigma is equal to dt. If you derive on both sides, 1 upon x sigma is equal to dt. How? इसका derivative 0, इसका becomes 1 upon sigma. Okay, 1 upon sigma, my bad. Then your, if I keep x on one side, everything on another side, it would be x is equal to 4 sigma into t, then mu this side, so plus mu. Okay, therefore your LHS basically becomes let us just put the limits wala thing also. If your x is equal to your lower limit, then your t ka limit would be L k y L k just L dash sorry y L dash have a look. यहाँ पे मैंने L substitute किया L minus में open sigma which is exactly written here. Similarly, if your x is equal to u, then your t becomes u dash. Okay, so your LHS basically becomes integration from L dash to mu dash. X के बदले it would be sigma t plus mu 1 upon root 2 pi वैसे ही. So into 1 upon, wait, I'm writing this in a थोड़ा अच्छा handwriting, plus mu 1 upon root 2 pi 1 upon sigma के बदले can I write dt? Yes, I can write. So dt e raised to minus half x minus mu upon sigma t आ गया ना, so t square. Okay, so let us simplify it थोड़ा. Okay, I'm splitting mu and sigma t का दो different integration. Okay, so it would be mu into 1 upon root 2 pi e raised to minus half of t square plus integration of sigma t into 1 upon root 2 pi e raised to minus half of t square. Easy, right? Now I will take mu out. I'm left with mu integration from 1 upon root 2 pi e raised to minus half of t square dt plus sigma bar integration from L dash to mu dash 1 upon root 2 pi e raised to minus half of t square dt. If you see this, okay, this doesn't look like a, oh sorry, मेरा highlighter select ही नहीं हुआ, lol, yeah, wow. Doesn't it look like a standard normal distribution like the previous case? So this would nothing but mu probability of your t is between L dash and mu dash, okay, plus sigma. If you see, there is a t right here, barabar. So you cannot directly solve this. Okay, if you solve this integration, it would be minus 1 upon root 2 pi e raised to minus half of t square from L dash to mu dash. Okay, this integration का ये आंसर कैसे आया? You can solve it by u into v, or else it is not necessary to show. You can write it directly as well. Okay, so this is nothing but u CDF of L dash, sorry, U dash minus CDF of L dash, okay, plus sigma. If you see, मैं mu dash डालूं तो यहाँ पे mu dash square आ जाएगा, which will give you the PDF of your mu dash. अगर मैं L dash डालूं, it will give you the PDF of L dash. So by this, okay, you would be basically done with your normal property का proof as well. These two proofs are important. You have to learn them. Okay. Now we'll be just solving some. आधा घंटा मस्त sum solve करेंगे. And with this, all these concept and everything would be basically solved. Okay. Then in the third lecture, okay, I will again see some concept. वापस वो concept के sums fourth lecture में. And with that, we are even done with our portion. Cool. So yeah, thank you.